Sorry about that. In the last video I just ran out of time, so what we're going to do is we're going to finish this off. So I divided the trinomial, right? It's basically a quadratic equation here, by 2, getting k squared minus 4k minus 12 equals 0. Factoring both, I had k minus 6, k plus 2. So that means our values for k are going to be, oh, that's our YouTube link from the last video. So it's going to be k equal to 6 and k equal to -2. Alright, so let's go up. Remember, your non-permissive values are k equal to plus or minus 2. So in this case, there's actually going to be a non-permissible value. That value is out of the question, so it's an extraneous solution, right? Extraneous root or solution. Okay. But the answer is k equal to 6. That will. You can double check that if you want. It will work. Plug it in, and you'll get both sides equal. Right, I can do that in my head. Let's do it in our head right quick. So we get 6 times 4 is going to be 24 minus 1 is 23. 23 over 8, and then you would just continue on, right? So it's subtract them. I thought it was going to be nice numbers, but it would work out. Right, but the -2 wouldn't work because it would give you a 0 there. It does work. You can check it. I'm not going to in the interest of time, so you can check that and it will work. All right. So let's look at a couple of word problems, and then we'll finish chapter 6. It says Colin Rose is about 24 kilometers downstream and back where he began. It says when the average speed of the current is 2 kilometers per hour, Colin can complete the journey in 9 hours. What is Colin's average rolling speed in the water? So that's kind of like a physics question. It's kind of neat. All right. So if we are going downstream and back, that means we're going 24 kilometers down, and up is 24 kilometers as well. Right. Fill in the chart. Chart helps you. Average speed. Remember, it says when your average speed of the current is 2 kilometers. So downstream, usually the current goes with you. So if it's downstream, it's going to be an unknown x plus 2. Okay. And obviously, if you're upstream, you're going against the current. So it's going to be your speed minus 2. Right? X is the unknown value here. Okay, there's average speed and time. So you probably do remember when you did physics and science 10, as well as in your physics 11, that the velocity is equal to distance over time, or speed is equal to distance over time. So time is going to equal your distance divided by your speed. And so essentially what we're doing is we're going to make an irrational expression here. All right, so it's going to be 24. We'll drop the units over x plus 2. And over in this here, we're going to have the same expression, only it's going to be x minus 2. Okay? And it takes 9 hours because we want to put it in time, right? So to make the rational equation, our downstream time plus our upstream time is going to equal our total time. That would be a very simple equation, right? And that's what we have. So our downstream time is given by 24 over x plus 2 plus our upstream time, which is 24x minus 2, and our total time is 9. And that's it. So it's kind of neat. We can bring in a physics question and solve this with rational expressions. You may have done something similar in physics, I'm not sure. But pretty straightforward, pretty neat question. And then we're going to solve for x. So the first thing we need to do, as you guys are aware, we got to find a common denominator. So the common denominator is going to be x plus 2x minus 2. So we got to multiply this whole equation by that. All right. So this has to be multiplied by x plus 2, x minus 2. I'm going to copy this because it has to be multiplied by this one as well, and that's multiplied by this as well. Put it in the front or back of the term doesn't make a difference. Now I'm going to copy this, so we're going to work on this. So the x plus 2 divides with the x plus 2, it's gone. The x minus 2 divides with this x minus 2, it's gone. And then we got it. Okay, so now again we don't have any rational expression. There's no denominators anymore. That's the whole idea. By multiplying by the least common denominator, it gets rid of all the denominators. So now we're going to multiply this and solve. Alright, so I'm going to clean this up a bit. So it's going to be 24x minus 48 plus 24x plus 48 equal 2, and we'll multiply this out, so the 9, and then with the x squared, right? So you're going to end up with x squared, so x squared minus 2x plus 2x minus 4. So these are actually going to be eliminated, right? And there you go. So I'll recopy this, copy, click like terms as I'm going to. We might as well do that as well. What happened there? So the 24x plus the 24x gives us 48x. Negative 48 plus 48 is gone. And then we're going to multiply 9 by x squared minus 4, so it's going to give us 9x squared minus 36. So our last step is to take the 48 over to the other side, right? So subtract 48 for both sides. I'm going to stick it in the middle here to put it in general form. Alright. And now what we'll do is we will, the easiest thing to do is factor out. And then we can actually factor out a 3 here. It's not really going to help us a lot, but a little bit. So we'll divide everything by 3. Just makes it a little less for the decomposition. So divide that by 3, we get 3. Divide 48 by 3, we get 16. Divide 36 by 3, we get 12. So now we're looking for two numbers multiplied together to give us 36, added together to give us negative 16. And those numbers would be negative 18 and 2. So using decomposition that we learned in grade 10, this becomes 18x plus 2, right? So this negative 16x becomes negative 18x plus 2. So now we're going to do our decomposition factoring, right? So we factor these and we get 3x coming out, leaving you with, x minus 6. And do the same thing with the 2, factor the 2 out, leaves you with x minus 6. Of course, that's why we did it. So group the two GCFs that you pulled out together and then the other one, and we end up with 3x plus 2 bracket x minus 6. Beautiful. And then set both of these equal to 0. Alright, drop the brackets, of course. 3x plus 2, and set them both equal to 0. So then we end up with x equals negative 2 over 3, right? Negative 2/3. And the next one here, we get x equals 6. Obviously, I know in physics you would say you can't have a negative speed, because it's direction, but the negative won't work here, because then it'll actually give you a negative time, right? So this is, as you guys are, you're aware of now, this is going to be an extraneous rule. It doesn't work for this particular equation. It has nothing to do with, in this case, it has nothing to do with the non-permissible values. Or non-permissible values, x can be plus or minus 2. It doesn't affect this question. So this means that Collins' average speed in still water, because that's when it's not moving, right, is 6 kilometers per hour, right? When you have a word problem, answer with a question, or answer with a sentence your question, right? and then you're finished there. All right. I'm going to end the video there, just so I'm not rushing through the next example, and then we'll do the final question on page 16 for the final question of the chapter. Thank you very much. See you again in the last video on page 16, the example with Katie mowing lawn. Similar, but a little bit different. Thank you.